Sorry about that abrupt ending. My computer decided to randomly shut down and perform a Windows update. So we're just going to pick up from exactly where we left off very quickly to move forward. So unfortunately, this lesson is going to now be recorded into 3 parts, which is okay. They're short lessons. So I believe we left off here. So I'll quickly make this sketch. So we had depth with respect to time, and we had 11 was our low, 16, 21, and I think I was saying I like to make little boundaries, and then we had 0, 3, 6, 9, and 12, and that was our time in hours. Okay, so I think that's where we left off. So it tells you at t equals 0, so when time is 0, it's at low tide, and low tide is 11 meters. So right here. And that's all the information that it gives you in terms of timing, right? The water depth in the harbor is 21 at high tide, 11 at low tide. One cycle is completed every 12 hours. That's a key thing that's going to help us, so I'll underline that. We need to find the equation. Find an equation, because again, there are an infinite number of equations you could use. One cycle is completed every 12 hours. Well, that means if I start at 11, 12 hours, 12 hours later, I should be right back to where I started. Okay, and that's our minimum point. How do we get the rest of our points? Well, if you have 2 min, in this case, minimums, or if you had 2 maximums, the other one, so the minimum, or in this case, the maximum, due to the symmetrical nature of sinusoidal functions, halfway between 0 and 12 would be my max. My mins are at 0 and 12. My max would be halfway, which would be at 6. So at 6 hours, I'm at my high tide. And you have to follow the pattern. Again, this is split into quarters. So I start here, right? At 3 hours, I'm on my equation of axis. I reach high tide. I start to come back down. So at 9, my next quarter, I'm on my equation of axis. And then I keep going. Again, notice there's only an arrow on one end because time is continuous, counting out to the right. However, there's not an arrow on the left side because that would be going back in time, and it's impossible to go back in time. Okay, so let's come up with our equation. Well, we know that C, which is our equation of axis, we already know that's 16, right? That's this line right here. Y equals 16, or in this case, it would be d of t equals 16. My amplitude, you could use the equation, or that's your distance under the curve from your equation of axis to your max or your min, which in this case, 1621, that's 5. Okay, my amplitude is 5. Now I need my k value, and we have that formula, period equals 2 pi over k. Now your period, for these word problems, your periods are going to be not in terms of pi, but in terms of units of measure, in this case, hours. So our period, how long does it take to complete one cycle? 12 hours. Now I'm not going to write hours because then you got 12h, you got another variable in there, might confuse some people. So 2 pi over k, solve for k. K equals 2 pi over 12, which means if you reduce that, k equals pi over 6. And for these questions, you're often going to get, almost always going to get, a k value that is in terms of pi. And that's good because when you want to use when you go to use your calculator, you want your calculator to be in radians and you want to use pi in there. So to come up with an equation, again, there are many different ways you could do this, just like our other examples that we did from our graphs. d of t equals, let's say you want to pick a sine graph. Sine typically starts right on your equation of axis and where it meets the y-axis. Well, the first time I hit my equation of axis is right here. And that is not my y-axis. I have shifted it right 3. And I'm starting by going up, so we know it's positive. Just to talk about it, conversely, you could have no horizontal shift, but you could start down here at 11. And that would be a cos because you would be starting at a minimum. And it would be a negative cos. And then you'd have no horizontal shift. And it can keep going there. The possibilities are endless. So depth with respect to time, my amplitude is 5. I said I was going to pick a sine. My k value is pi over 6. And then it's going to be t, right? It's d of t, not d of x. So t, shifted right 3, so minus 3. My equation of axis, plus 16. I didn't ask a follow-up question to this, but I could say something like, what is the height at 10 hours? And you would make sure your calculator's in radians, and you would find d of 10, so put 10 in for t, and you would type that all in your calculator, and you'd get an answer. And you know that it should be between 11 and 16 meters high. Example number 4. A point on the ocean rises and falls as waves pass. Another water question. Suppose that a wave passes every 4 seconds, and the height of each wave from the low point to the high point is 0.5. Assume the water level is 1 meter and is at water level at t equals 0. Always start off with a sketch. And on your tests are going to say make a sketch to supplement your answer. All right, so a wave passes every 4 seconds. That's giving you the period, right? It repeats itself every 4 seconds, so there's my endpoint. And remember, sinusoidal functions split into quarters. So what's halfway to what's halfway between there, easy peasy, it's going up by ones. And that is time and seconds. Height. Okay, so you get a picture of your x-axis. In this case, our x-axis actually, even though it's in time, it represents the seafloor bottom. Okay. So it tells you water level is 1 meter. So right there. That's our water level. So between the ocean floor and the water, there's 1 meter of water. And it tells you that the height of each wave from the low point will obviously be 1 meter, to the high point is 0.5. So if I add 0.5 to 1, that gives me the highest point, which would be 1.5 meters. Okay, so that's not bad. Assume the level is 1 meter and is at water level at time equals 0. So we're going to assume that at time equals 0, it's at 1 meter. One thing we have not found yet, so we have our low point 1 meter, we have our high point 0.5. I need to find halfway in between that. That's my equation of axis. What's halfway between 1 and 1.5? You could add them and divide by 2. Hopefully everyone knows it would be 1.25 meters. And again, we can make little target boundaries. We know that my graph only lives between those 3 lines. At time equals 0, it's at water level, which is 1 meter. So down here. It passes every 4 seconds, so that means that at 4 seconds, you are back to the beginning, where you started. Again, how do I get the rest of my points? Well, halfway between two minimums would be the maximum. So at 2 seconds, we're at our maximum. There's our wave. And then halfway in between those, you're on your equation of axis. So this looks very similar to the last graph that we had. Are these questions always going to say they start at a max or min at time equals 0? No, not always. Sometimes it'll start at different points. It might start at the equation of axis. It might start at another random point. But just to start off with our first couple of examples, we're keeping it relatively easy. So now we're ready for making an equation that could model this. We've already calculated our C value. It's this, right? Y equals 1.25. And we'll call this, I guess I didn't label my y-axis. We'll call that height in meters. So I'll call this h of t, height with respect to time. I know my equation of axis, 1.25. My amplitude is this distance right here between my equation of axis and my max or my min, which is 0.25. Okay, so far so good. My period is 4 seconds, and it relates to that equation. So 4 equals 2 pi over k, solve for k equals 2 pi over 4, which means when you reduce that, k equals pi over 2. Now our phase shift. Let's give cosine some love. So h of t equals, now remember cosine always starts on a max or a min. And when it's on the max or min, it's normally on the y-axis. If I was to pick this right here, which is what I'm going to pick, I'm at my minimum. Cos normally starts by going down from a max. I'm at the min, making my way up. So that means it's negative. So negative 0.25 cos pi over 2 t. Now I don't have a phase shift. I didn't shift right or left. I'm on the y-axis. So we can just leave it like that. And in fact, I didn't even need square brackets. And then plus 1.25. Another cos graph you could have picked, or equation, you could have, if you don't like the negative aspect of it, or if that rattles your brain, you could have picked the max, which means it shifted right 2. So I'm not going to write it, but I'll just verbally go over it with you. You could have kept it positive, so 0.25 cos pi over 2, but this time it would be t minus 2 because you shifted it right 2, and then plus 1.25. Again, if I was to ask you a follow-up question, how high is the wave at 1.5 seconds? Make sure your calculator's in radian mode, put in 1.5 for t, and away you go. Just calculator work. So again, I apologize, your lesson split into 3 parts. It's okay, you still got all the same information, 3 relatively short videos, especially the last 2. So here's some work. Before you do this though, again, make sure you check D2L for the actual questions and make sure this is part B, make sure you watch part C. So there's part A, this is part B. You've already watched A, you're now watching B. Watch part C, which is just another couple of examples, pretty short. And then you can tackle this work and start some review. And then you have your test. Now, one thing I want to bring to your attention as you're watching this, just because the part C was pre-recorded from a different semester, your test is in the morning on Friday, May 21st. Please be advised that on that day, the Teams meetings that I'm normally running from 10:30 to 1:30, I will be changing and I will be in Teams instead of 10:30 to 1:30, I will be in there from 9 until 12. So from 9 a.m. till 12. So still for 3 hours, but just the first 3 hours of the day. The next important thing to note, please make sure once you're in your test, it's not just the end of time, like it's not the end of the week and away you go for your long weekend. There's going to be extra time because you're starting your test earlier. There is a first lesson to do for the next unit, which typically the next unit is one of the tougher units of the course, especially in class. But virtually, there's not as much memorization, so maybe it won't be as bad. Who knows? But again, make sure you watch the first lesson, which it's listed there in the daily plan for D2L, of the next unit before you go on your way to your weekend. So do your test, get that over with, have some lunch, take a break, whatever. Watch the first lesson. And then if you didn't know already, after the May long weekend, we are together Tuesday and Wednesday, and then you go to your next classes for Thursday and Friday after the May long weekend. So you will have one lesson on Friday after your test, and then you'll have, haven't exactly mapped it out perfectly yet, but another day-ish worth of lessons on the Tuesday when we come back, and then you will have your test on the Wednesday afternoon. So there still could possibly be one lesson on Wednesday morning of your test. We'll see. We'll see how it goes. Okay, that's it. Long enough. Make sure you watch Part C and get going on the work. Thanks for listening. Happy mathing.